Hello everybody, my name is Wyndham Batchelor and we are working on developing a novel glaucoma model using AFM nanolithography. So, what is glaucoma? Glaucoma is a disease of the eye that leads to optic nerve degeneration and retinal ganglion cell death. Glaucoma affects around 60 million people worldwide, making it the #1 cause of irreversible visual impairment. The retinal ganglion cells, as Zenith mentioned, are an inner layer of your retina that receives information from your photoreceptors and transmits this information through your optic nerve to your eye. With elderly populations around the globe skyrocketing, glaucoma is poised to become an even bigger burden to society than it already is. Once these retinal ganglion cells die, vision is lost permanently. So, right now, there are several treatments that can be used to slow the progression of glaucoma. Intraocular pressure lowering drugs, which the high intraocular pressure is one of the main drivers of glaucoma, so these lower the pressure to reduce the damage, as well as laser treatments and shunts. However, these treatments suffer in many ways. They can only lower the intraocular pressure, which only slows the progression of the disease. Many people will still continue on to lose vision, even with these treatments. And it does nothing to restore vision already lost or any damage done by glaucoma. So in the future, cellular therapies and regenerative medicine is needed to actually restore these retinal ganglion cells to the eye. But so far, progress in developing these treatments have been slowed by lack of a suitable glaucoma model. Right now, mice and other laboratory animals are used, and these don't really mimic well the complex pathogenesis of glaucoma. Nor are they a very suitable environment for doing experiments because there's a lot of noise that gets conflated with signal, and it's hard to isolate different factors in these experiments. So what we propose is using atomic force microscopy nanolithography to build a novel in vitro human glaucoma model. We plan to use two different modalities, dip pen nanolithography, which puts material on a surface, and scratch nanolithography, which removes tissue, or removes material on a collagen gel scaffold to enhance the scaffold with mechanical, topological, and chemical cues. And then we'll put RGCs on the scaffold to simulate the RGC layer, and then we will subject this to high pressure and record responses to see how well our model simulates glaucoma.